Good morning, class 8. Today we'll be dealing with the last topics, some of the last topics of your last semester chapter, chemical reaction. Okay? Now, in this first topic that we need to cover is the importance of neutralization reaction in our daily life. Okay? Now, what is neutralization reaction? Previously in my videos, I've already told you when an acid reacts with base, it gives off salt and water. Okay, now it is very important to dilute the content to reduce its acidity or to add in something with base to reduce its basicity. Okay, so it is very important to neutralize some reactions, else an acidic reaction will be vigorous high and basic reactions will be very slower rate. Okay, now neutralization reactions, we use it in our day-to-day life also. Okay, the best examples are bee insect sting. Now insect sting means what? Bee stings you, the stings of the bee is acidic in nature. So what happens, people say no, when something has stinged you, quickly apply lime over it, chuna laga lo, right? So that is what it neutralizes the acidity content of the sting. Okay, and wasp stings are alkaline and it can be neutralized with vinegar. Wasp is, you call it hadda. Okay, and this bee sting is madhumakhi. Okay, so there are different ways to neutralize the acidity content. Why? If the sting, you will not neutralize it, you will have big marks over your faces or wherever you have been stinged. Then indigestion. You see that your stomach carries around various hydrochloric acids, right? And too much of it leads to indigestion. Indigestion we call apach. Okay. Now what happens to cure this indigestion? You need to neutralize the acid content in your body. So this happens when you add acid, excess of baking soda, or you use Eno. So what does this Eno do? It quickly neutralizes the acidic content in your body and hence you are able to digest the food. Okay, next is your soil treatment. So what happens, if the soil is acidic, it can be treated with bases like quick lime, slag lime, chalk to make it neutral so that the crop or plant may grow well, because neutral soils are best for the growth of plants. Okay, and secondly, basic soils are neutralized by adding sulfate salts. To neutralize acid, you need to add slag lime, chalk, quick lime, and to add you add sulfate salt to make neutralize a base. Clear? Then in factory waste, what happens? Liquid waste from factories are often acidic in nature. So if it reaches the river, it will destroy and kill sea life of animals in many forms. So neutralizing the waste with slag lime can prevent this. Okay, so this is all about your neutralization reaction. Now we will talk about metal activity series. On the basis of rate of reaction of metals with oxygen, first oxygen, water and dilute acids. Oxygen, water and dilute acids, it has been arranged in decreasing order of their chemical reactivity. That means what is a metal activity series? A list of metals, okay, arranged in decreasing order of their chemical reactivity is known as metal activity series. Okay. Now among the commonly known metals, you can see potassium is kept at the top and least reactive metal platinum is kept at the bottom of the list. Depending upon their reactivity with the oxygen, dilute acid and water, this metal activity series decides what metal, when reacts with oxygen, the reaction will be very high, and that's why you see that gold, silver and platinum in the slide are at downward. That means they are very unreactive, less reactive, and that's why they are very costly in nature, because they do not react with any other metal very quickly, even with water, oxygen, or any dilute acid. Clear? So this is about your metal activity series. Now we will be talking about types of chemical reaction on the basis of energy. Now what happens? Energy can be either broken to give something or to absorb the heat. That means what is happening, what is the role of energy in a chemical reaction? It involves in breaking the chemical bond between the atoms. Now when you break the bond between the atoms, you require a lot of energy, right? So this energy can either be absorbed in the reaction or it can be released out in the reaction. So depending upon the absorption or releasing, chemical reactions are of two types: exothermic reaction and endothermic reaction. The word exo means exit. Exit means given out. So a chemical reaction in which heat is given out is called exothermic reaction. It causes a rise in temperature. Very good example in your book is given of carbon dioxide. Okay, carbon dioxide is formed when carbon reacts with oxygen. A lot of heat is given out in this reaction. Similarly, in respiration also a lot of heat is given in the form of ATP. Clear? Now the second one is your endothermic reaction. The endothermic reaction is what? In which heat is absorbed in a reaction. That means you do not give out the heat. Heat is absorbed in that particular reaction, and as a result it reduces or it makes the reaction fall in temperature. Very good example is given when nitrogen and oxygen together are heated at a temperature of 3000 degrees centigrade, nitric oxide gas is formed. Okay, and this is known as an endothermic reaction. Now you will see the chemical reaction is given in your book clearly. Okay, then we'll talk about very important topic, that is metal oxides and non-metallic oxides. Now what are metallic oxides? Metallic oxides or non-metallic oxide, the word itself says metal, and oxide means oxygen, somewhere work of oxygen. So an oxide is what? It is a compound that reacts with oxygen, okay, and it combines chemically. So oxides means oxygen reacting with can either react with metal or with a non-metal. So in this slide you can see that metallic oxides can be divided into two parts: basic oxides and amphoteric oxides. And non-metallic oxides can be categorized into two parts: acidic oxides and neutral oxides. Right? So this is what your classification of metals and non-metals. Now metallic oxides are formed when metal reacts with oxygen on heating or without heating. Suppose in your book the example is given of sodium when reacts with oxygen, it forms sodium oxide. It is a metallic oxide because sodium is a metal reacting with oxygen oxide, forming an oxide, that is sodium oxide. When calcium reacts with oxygen, it forms calcium oxide, and so on. So these are certain examples of your metallic oxides. Now metallic oxides can be of two types, I told you: basic oxides and amphoteric oxides. So basic oxides are what? Most of the metal oxides are basic in nature. Now basic oxides, how will you know that they are basic in nature? When dissolves in water, it produces soluble bases known as alkali. Alkali soluble bases. Now hydroxide will be formed. You can see clearly in the slide, it is mentioned. In your book on page number 83, you can go through it. Early beta C, sodium oxide I said. When oxide reacts with water, it is soluble in water and hence form an alkali. So you can see sodium oxide Na2O when reacts with water H2O, it forms sodium hydroxide. Okay. Then potassium oxide K2O when reacts with water, it forms potassium hydroxide. Okay, and I told you very well that bases, when we put litmus paper in the solution, it turns into blue color. So it will show that it is basic oxide. Next comes your amphoteric oxide. Now what is amphoteric oxides? Metallic oxides like zinc oxide, lead monoxide, aluminium oxides are called amphoteric oxides because they have a tendency to react both with acid as well as bases. So amphoteric oxides are those oxides that react with acid also as well as bases also. Very common example is your zinc oxide. ZNO, zinc is an amphoteric oxide. Mark it. So what happens when zinc oxide ZNO reacts with HCl? It forms zinc chloride, ZnCl2, and water is released. But when zinc oxide reacts with a base, sodium hydroxide NaOH, okay, what happens? It forms sodium zincate and water, that is Na2ZnO2 plus water. So this is your amphoteric oxides. Now in your book there is activity 10 given. In this what you will do, you will take some copper carbonate. Copper carbonate is what? Your reaction says CuCO3, copper carbonate, and a green solid, which is a green solid, in a hard glass tube, and you will heat it for some times. What will happen? You will see a colorless carbon dioxide being released and a black solid as a residue is left. Okay. Now what happens? A gas that is evolved is carbon dioxide and the black residue that is left is your copper oxide, which is again a metallic oxide. So the reaction says when copper carbonate reacts with heat, it forms copper oxide and carbon dioxide is released. Last topic of your chapter is your non-metallic oxides. So what are non-metallic oxides? They are oxides that are formed when non-metal is heated with oxygen. Now non-metals are like carbon, sulfur, phosphorus, nitrogen, hydrogen, etc. So you can see there are so many reactions. You yourself can write those reactions. Carbon when reacts with oxygen will form carbon dioxide. Sulfur when reacts with oxygen it will form sulfur dioxide. Nitrogen when reacts with oxygen it forms nitric oxide, and so on. Clear? And what will happen? This non-metallic oxides like carbon dioxide, sulfur dioxide, trioxide, phosphorus pentoxide, they are all acidic in nature, and hence when you will put litmus paper in this solutions it will turn out red, showing that it is acidic in nature. So with this we complete the chapter. I hope there is no confusion in this chapter. If so, you can discuss it in the group. Have a nice day. God bless you all.